Be curious and critical in joining the programs and enjoy the class. Let's make our class as
Hi, future engineers. Welcome to our first podcast on engineering concept for civilization. This is actually the podcast that is part of the lecture that we have at the Faculty of Engineering at Universitas Gadjah Mada. And the name of the lecture, as I said earlier, Engineering Concept for Civilization. Together with me now is Professor Nizam. Prof. Nizam, apa kabar? How are you?
Good morning, Andi. Selamat pagi, good morning.
Selamat pagi, everyone.
Future engineers.
Right. So, Prof. Nizam and I will be tasked to take care of this lecture, Prof, right? The name of the lecture is once again Engineering Concept for Civilization. This is going to be a new approach, if I may say, of the lecture. So as Prof. Nizam said earlier, this is going to be a teaser for our lecture, right, Prof? So the student will be able to see this podcast first before they do the lecture, but it doesn't mean that this is enough for them.
Yeah.
Right. What do you think?
It is not the lecture, but it is a teaser for the lecture.
The teaser for the lecture, right? Okay. So this is going to be the teaser for the lecture. So students will need to see this, but then to continue with the real lecture and also reading materials. All right. Prof. Nizam, once again, thank you very much for coming.
My pleasure.
All right. Because we are going to teach together in the class.
Indeed.
I would like to also know, me myself, and I think students also would like to know, why do we need to have this lecture? And then the specific question is that why there's the word civilization there.
Indeed.
It's a big word, Prof. So why do you think engineering or engineers actually important in this case for the civilization?
Yeah, indeed. Thank you, Andi. I think it's very important to relate between engineering and civilizations.
Right.
Because civilization itself born through the creations of people,
Right.
creating things
Right.
to make life easier,
Right.
and to protect people from
Right.
the elements.
Okay.
So engineering and civilization is two parts of the same
Okay.
coin.
Okay.
There are culture, there are civilizations because of the capacity of the people, of the human being, in creating, shaping the world they live
Right.
in.
Oh,
So
right.
this is the same coin,
Coin,
the
like
sides of
the
the
two side coin. All right. Okay.
between civilizations and engineering, actually.
Okay.
But formally, we can say that engineering born after the, say, 18th century.
Right.
Formally, but actually,
Actu-
people from out of Africa will
Uh-huh.
start making tools
Right.
and shaping the world that we live in through engineering creations.
So that was also
So
engineering.
That is
Right.
also engineering.
Right.
We first create the first wheel that can bring
Okay.
us from place to place. We create ships to bring us across the sea.
Right.
We build pyramids, we build
Okay.
monuments, we build house to
Okay.
protect us from rain,
Right.
from weather. So that is why we should remember that
Okay.
engineering and civilizations is two sides of the same coin.
All right. However, Prof, if we look at from like a narrow perspective, engineering or engineers is closely related to building things,
Yeah.
building object. That's what people might think about when they think about engineering. How does it work that is actually go beyond just creating things?
Yeah. Yeah, we create things. Actually, engineers do two things.
Right.
One is to make life easier,
Okay.
and
Right.
second is to protect life from the elements.
Okay.
We create buildings so that we can stay safe when it is rain,
Right.
from the weather.
Mm-hmm.
We create roads to bring us from one place to the
Okay,
other.
right.
Simpler. We create bridge so we can cross the river
Right.
safely.
Mm-hmm.
And also that's to make life simple and to
Okay.
to save us from the element of the
Right.
danger from the
Okay. Okay.
from the environment. So that is the basic things.
Okay.
Human as Homo factor, as the species that create things,
Right.
and that in creations that creating things is the root of engineering, what we now call engineer. We create things
Right.
as engineers.
Okay.
And human also, because of his or her curiosity, want to explain things.
Right.
That's how we then learn science.
Uh-huh.
But engineers go beyond that.
Okay.
After we know how things works,
Okay.
then we try to use that principle, that scientific principles, to build those things to be more effective, more
Okay.
efficient, and serve the purpose.
Okay. In this case, you may say, science will make you understand how things work,
Yeah.
but engineering will enable you to create something to
Yeah.
basically solve problems, something like that, right?
Solve problem,
Okay.
yes.
Okay. Prof. Nizam, we are going to have engineering students attending this class, right?
Indeed.
Okay. Because you say that engineering is actually beyond creation or beyond making things. What will the student learn from this lecture that we are going to give them?
Yeah. Yeah. This lecture actually to put engineering in perspective,
Okay.
because sometimes engineers they do things and
Yeah.
they have duty to serve their purpose, like
Right.
I mentioned earlier.
All right.
To create things to make life easier,
Mm-hmm.
to make things to make life safer.
Right.
In his or her creations,
Mm-hmm.
they might also abuse the knowledge, the technology,
Okay.
to make life or to make nature becoming worse instead of
Okay.
getting better.
Right.
So to put the engineering in perspective, we make these courses
Okay.
to bring a holistic view
Okay.
of
Right.
what engineering roles are, what their responsibilities are,
Mm-hmm.
and how they should do things in the right way, in a better way,
Okay.
to make the world a better place for
Oh,
everyone.
that is a very good point. So, in other words, I think they will also learn something outside of the engineering somehow, right? Is it correct? Prof?
Exactly.
Okay, right. Okay. Now, the next step is that solving problems, I think, is the thing that we mentioned earlier. Can you elaborate more that actually engineering is here to solve problems?
Yeah. That is the most fundamental elements of engineers. Engineers is do things to solve problems.
Okay, right.
So not just understanding the problems, but solving the problems. That
Okay.
is the most important things that differentiate engineers from the rest of the
Aha.
professions.
Right, okay.
Yeah. And sorry, you asked, but
Solving problems.
solving problems. Yeah.
Yeah.
In solving problems,
Mhm.
we have to have good foundations in
Uh-huh.
how to solve problems.
Right, right.
In answering the questions, in delivering the
Okay.
solutions, we need science.
Okay,
We
okay.
need math.
Mm-hmm.
We also need to understand the people. We need also to
Okay.
understand the environment, the
Yes.
ecosystem,
Mm-hmm.
the social system.
Mm-hmm. Mm-hmm.
Even we need to understand how people works,
Okay.
the psychology of people,
Yes.
the behavior,
The behavior.
the behavior of people using the
Mm.
engineering products. For instance,
Yeah.
if we design a cup,
Okay.
then we have to think of how people use cup for their
Right.
purpose.
Okay. Okay.
That needs us to understand how people behave. If we
Ah,
build a house, we have to understand what the people needs about that house
Okay.
to be. If we build a road,
right.
we have to make sure that it will be safe for people, maybe a bit sleepy when
Okay.
driving.
Right.
We have to understand that.
Okay. Okay.
So to make the
okay.
road
Okay.
slightly curved,
Uh-huh.
to
Uh-huh.
make them aware anytime. Those sort of things
Right.
need us to
Right.
when we solve or
Okay.
deliver solutions. A good engineer
Okay.
should think that this solution will not create another problems.
Ah.
So
Okay,
that
interesting.
needs us to be holistic
in this
approach
case.
of,
So first, it
solving
is a
things.
problem solving. That's having a
Solving.
point. Second is
based on scientific
based on scientific,
and science that support our
Okay.
decisions.
meaning that it is also collaborative process.
And in the process, we could not work alone.
Okay.
So by nature, engineering involves many people to
Right.
work together, many disciplines to look together at the problems.
Okay.
So the solution that we deliver will already been looked from various perspectives.
Right.
And in delivering the solutions, we work with all
Other disciplines.
other disciplines.
Okay. Right. Prof. Nizam, can you maybe give an example, like
Yeah.
a major breakthrough that we have in the world? Probably you can think of something that actually that breakthrough or invention, whatever we call it, actually result of a collaboration of many disciplines. If you can give an examples.
Yeah, there are a lot of,
Okay.
well, from the simple thing like this microphone.
Okay.
If we look at this microphone, this is what we can think of, this is the results of electrical engineers
Okay.
doing the electronics.
Mm-hmm.
But how about the case?
Okay.
This is metal.
Right.
Who create these metals?
Right.
From the mine.
Okay. Mining. Right.
Mining. So then we know that the geologists are
Other.
working on
right.
that.
Okay. Right.
How geologists find that mining
Mhm.
sites? They need
Mapping.
geodetics.
Yeah. Right. Okay.
So there's already these simple things. Already so many disciplines are involved.
Involved.
So when we talk about the technology,
Uh-huh.
how come that our sounds can go into this device
Uh-huh.
and can be recorded?
Right.
So there's a lot of science in
Right.
there. So this everything.
Okay.
Everything we create.
Right.
Never we can do it alone.
Alone. So in order to understand this, we don't need to think about something really big. Even small object in front of us
Even
already
small
tell us that.
Yes. Already tell
Okay,
us about
very-
that. So that
very,
is
very interesting.
Yeah. If we look at a big project like
Yeah.
a dam
Okay.
or an airplane, so there's thousands of engineers.
Okay.
We can see in a mission case when we first make the
Mm-hmm.
Indonesian-made aircraft,
Yes.
the N250.
Yes. It was
So that's
1995.
Thousands, yes,
Okay.
1995.
Right.
Thousands of engineers work day and night to deliver that.
To deliver that.
Takes
Okay.
years to
Okay.
design and make and deliver
Right.
the plane to take off.
That actually reminds me of. I remember, Prof, when I started my study back almost 30 years ago.
Yeah.
We were told that engineering is really great. The faculty, which I agree
Yeah.
somehow, but then the more I learn, the more I understand that we actually have to also understand the non-technical aspects
Indeed.
of life.
Indeed.
So can you give a message to our students about that, Prof?
Yes. My background is civil engineering.
Right.
In civil engineering, there's no way you can build a structures without communications with the people you serve,
Right.
without communications with the people affected by what you build.
Mm-hmm.
For instance, I give a very good example of, I think, an excellent engineer, the former Minister of Public Works, Pak Basuki,
Basuki.
our alumni.
Yeah.
I think he is a really good engineer.
Okay.
He know how to speak with local when we built the roads through the middle of nowhere,
Like
in
on the
Papua,
rural areas.
In rural areas, he can play guitars with the locals,
Yes.
sing together with the locals,
Right.
Communications,
Right.
communicate with. That the coming of the infrastructures
Right.
is not to disrupt them, but
Okay.
to serve them. So that way of communications is really needed for
Right.
every engineers to have that competences.
Right.
Understanding what the people needs, understanding what their concern, understanding what the pain point of the people that need their service.
Okay.
And also the people that might not need their service but impacted by what we build.
Okay. Right.
If we build a road, then it will block one village from the other.
Right.
So we have to empathize with how then the people from one village can still move to the other across the road if
Okay.
there's say a toll road
Right.
to build. So that aspect need to be in our mind.
Okay.
We could not be selfish
Right.
just serving the clients, but we also have to look at the impact of what we build,
To the
impact
society.
of what we design, what we plan to the society.
Right. Right.
So bringing goods for not only for the clients that we
Okay.
serve, but also to the society, to the community, and to the world.
I think you made a very good point about we actually build something, or engineers build something to help them, right? But sometimes without without knowing it, sometimes
intentionally, unintentionally.
sometimes it disrupts their life, right? So
Indeed.
we really need to understand it, right?
Yes.
So it means also this is also related to environment, Prof. Can you elaborate more about that?
Yes, very much. So, well, in the beginning, people want to move from one place to the other
Right.
as quickly as possible.
Hmm.
Engineers invent
Maybe cars,
automobile.
yeah.
Automobile.
Hmm.
And now we see that automobile actually is not a good way to transport people from one place to the other because it creates pollution, it creates noise, it creates many issues.
Okay.
So engineer has to come up with some solutions how to make this less polluted by say creating electric vehicle. Does it solve the problems? Perhaps it solves somehow,
partially.
partially, but then the fuel for the electric vehicle, the battery charging, the electricity where it comes from?
Maybe coal mining.
From coal mining.
Right. Okay.
So yeah, that sort of things. Unintentionally, we solve the problem partially, but not holistically.
Okay. Okay.
So
okay.
that issues sometimes beyond our sights, beyond what we expect in the beginning. So intentionally we create problems outside what the solutions give. So that is a very important thing that we have to be aware of and know how to do that. That is part of our course.
Okay.
So how to make an engineer as holistic, all-rounded engineers.
Rounded engineers. I think it's a very good keyword.
Yes, all-rounded engineers.
Meaning that if I may repeat a little bit, collaboration with other disciplines is really important. Can you elaborate more? For example, how collaboration between engineers, like lawyers or maybe economists and environmentalists, will actually make the solution more effective or better?
Yeah.
Right. How do you see that?
Yes. Yes. Again, as I mentioned earlier, everything that we create impacted not only the clients that we serve, but the society at large. And since we live in a society, there are rules, there are regulations, there are laws. So we have to understand that. Of course, we don't need to look at all the rules
and articles,
laws,
conventions,
which is beyond our competencies. So we need to work together with lawyers.
Good point.
In building a new roads, it costs a lot.
Okay.
So how to finance the road constructions?
Okay.
A toll road, a railway, whatever you name it. We have to. Engineer is not only building things, but also we need to build that in most cost-effective way.
Cost-effective ways.
And we don't need to learn about economics very deeply to understand the value of money and how to take credits and things. So we need to work with economists on how to finance the project. How to make it more cost efficient, more cost effective. Public-private partnerships. So those things we need to cooperate with economists. And for instance, if we build an airport, it will replace people who used to live there. You have to empathize with them if they have to
Indeed.
be replaced
Indeed.
for this where public service.
Yes.
We have to understand their psychology. They live there for ages and
Maybe.
now have to move
Yes.
to other place.
Right.
So we have to empathize this, understand them, give them solutions.
Right.
The in the view of them, not
Okay.
in the
Okay.
view of us.
So using their perspective,
This is
basically.
their perspective
Not
on giving them the solutions.
Right.
And for that, we need sociologists,
Yes.
we need psychologists,
Okay.
we need anthropologists. So
Okay.
we have to work with so many disciplines, not just with the engineering border,
Okay.
but also with other disciplines.
Right.
And for us to able to communicate with so many disciplines,
Right.
somehow we have to understand how they also think about their disciplines.
Yes.
So it's about the communications.
Right.
How can we communicate if we
Yes.
don't understand your language?
Correct.
So we have
Correct.
to somehow understand the language of the lawyers,
Yeah. Yes.
the language of the politicians,
Uh-huh.
the language of the economists,
Okay.
the language of the people.
Right.
So that is part of the things that an
Yes.
engineer, a holistic
Right.
engineer, should somehow understand and try to learn.
Very, very nice, Prof. Nizam. Now on a personal note, I understand that Prof. Nizam has been working a lot with different disciplines, different people, because you have served actually in the ministry for quite some time, right, Prof? I think I can learn from you how you manage to interact with different people from different discipline. That I think somehow enriches your your knowledge and your ability to deal with people, right? Can you share a little bit more about that?
Well, thank you. That's a bit too,
Alright.
a bit too much. But yes, I think what we need to do is
Right.
using the design thinking.
Oh,
We
right.
start with empathizing. So we understand, we speak from the point of view of
Of
the
others.
people that we speak
Okay.
into, not
Right.
just from ourselves.
Okay.
So that is the most important
Mm.
aspect, I think,
Right.
of communications.
Okay.
If we look self-centered, too much self-centered
Mm.
in communications,
Right.
then that will be difficult to make the connections
Okay.
and understand and empathize what the need of
Yeah. Of others, basically.
others.
Okay.
Basically.
So basically, you say the word empathy. I think this is very,
Yeah.
very important over
So
there.
that is part of the design thinking that we will learn later on.
Okay, in the classes.
our class.
Okay,
yes.
great. So in other words, if I may say, or conclude a little bit at least, if we fail to collaborate with other discipline,
Yeah.
that might lead to the failure of the
failure of the
activities or
our-
project, right?
Yes, our
Okay, because I also see a lot of, for example, software. Our friends from electrical engineering or informatics, they could of course build the software,
yeah.
but sometimes the software doesn't
Yeah.
really work as we expected, right?
Yes.
I think the aspect is probably non-technical, right?
Yeah.
Right.
Yeah, in software engineering, we
Ah.
know that UI UX or
Right.
user experience, user
Right.
interaction is very important.
Very important.
And it is a new field in itself even.
Yeah, right.
So the
okay.
same with everything. If we design tools, we
Okay.
have to understand how people use their tools. Sometimes we
Okay.
forget about the people that will use our product. So that is part of
Yes.
what engineers should.
Right. So sometimes the failure is not actually not necessarily caused by the
Caused by the
technical
technical
aspect, but
aspect.
others.
But the interaction of the
Right.
thing that we create with the people that use
The product. Okay.
the product.
Prof. Nizam, you also mentioned about intentionally engineers would like to provide solution,
Yeah.
but in reality, sometimes we also cause problems in the
Yes.
process.
Yes.
Maybe environment or
Yeah.
other social problems. This, I think, the domain of the conversation, I think, is closely related to ethics.
Yeah.
So in this case, I think
Yeah.
engineers really need to pay attention to this.
Indeed.
What do you think about that?
Yes, very much. Very much indeed. That because what we create as engineers affects safety,
Right.
health, and well-being of
Mhm.
people who will use or affected by what we create.
Right.
This is very important for engineers to work
Mhm.
with ethics,
Okay.
with morality,
Mm.
and with integrity.
Right.
Without that, engineers can, well, become a dangerous people,
There you go.
a dangerous
Right.
person.
Right. Right.
So we have to make sure that engineers that comes out from
Our faculty.
our
or university?
faculty will be a humanist engineers.
Okay.
Engineers that work with ethics,
Okay.
with morality,
Mm. Mm.
with integrity,
Right.
and that is something that
Okay.
could not be compromised.
Okay. That's a very strong statement, I think. Maybe our future engineers would like to know maybe real examples.
Yeah,
If we engineers fail to
yeah,
basically apply this ethics,
yeah,
what can happen, Prof?
yeah. Just imagine
Mhm.
you build a tower of 50 floors.
Okay.
And instead of using steel reinforcement with a size of, say, 30 millimeters,
But the right spec,
you
basically.
use
Mm.
25 millimeters.
Uh-huh.
Less than. Perhaps in calculation it's still, well, almost safe.
Yeah, very
But
minor.
that almost is very dangerous. We see many structures fail
Okay.
because of that playing with the standards.
Okay. 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 So they don't comply with the standard, basically.
We don't comply with standards.
Right. Okay.
Well, the impact is very, very devastating.
Okay.
Imagine if you build a dam
Okay.
and you compromise the structural integrity,
And the specs, right?
structural
Okay.
integrity, the specifications, the
Right.
standards. What will happen if it collapses?
Uh-huh.
Thousands of people will be flooded, and well, there are already
It might take
many.
life also.
Well, there are already many
Examples of that.
examples of engineering
Right.
failures
Okay. Right.
caused by lack of integrity of the engineers.
So it means that you're saying that ethics is really important, and certainly this is going to be
And
part of the lecture, right?
Yes.
So how are you going to integrate that, Prof, into the classes that we are going to have?
Yeah, I think
Okay.
we should bring about case studies.
Okay. Right.
Yeah, because ethic and morality is sometimes very hard to guard,
Uh-huh.
and to
Right.
yes, to make sure that what we do will not compromise
Okay.
the safety, the standard,
Right.
especially of what we build, or what we would create.
Create.
So, in facing with
Yeah.
dilemma of compromising things,
Right.
it's very important for
Uh-huh.
engineers to keep their faith, to keep their what you call it, their integrity
Integrity,
in
right.
delivering the engineering ethics.
Okay.
Code of ethics. Every
Ah.
engineers have the code of ethics.
Yes.
That is very important as your guiding rules.
Uh-huh.
Never to compromise that engineering
Code
of
of ethics. Okay. So in a practical perspective, we are of course going to teach also the code of ethics at first. But as you said earlier, of course, this is not only about memorizing something, right? About remembering, but how to apply that. So
Yeah.
that's why we are going to bring the
Yeah,
case
yeah.
studies and
Indeed.
problem-based learning, something
Yeah.
like that, right? Okay.
Yeah. One simple rule of thumb is that
Hmm.
when we challenge with that kind of dilemma,
Right.
reflect and put yourself as the one that will be affected with your decisions.
So put
yourself
into their shoes, right?
Into their shoes.
All right. Okay.
Yeah. Will you be happy
If
in having at their shoes
okay.
when
Yeah.
your decisions was implemented,
Okay.
implemented.
Right.
That
Okay.
will be the litmus test
Okay.
for your decisions. Is it the right decision or not?
So basically, in a simple language, it's like a role play sometimes.
Yeah.
So you imagine
that's
that you play the role.
Actually, that's empathize.
Empathize. Okay.
Yeah.
Right.
So put yourself
In
on
their.
the shoes of others
Okay. Empathize. Right.
to see and to reflect your decisions. Is that the right decisions or not?
Okay. Very, very, very interesting, Prof. Now we can move forward a little bit. We have this terms, Prof, the jargons like industrial revolution.
Yeah.
We believe we also talk about that later on in our class, in a maybe later class.
Yeah.
How has engineering, in this case, in your opinion, evolved or changed over time? And now we are facing this industrial revolution 4.0, we call it.
Yeah. Well, actually, engineers always evolving. Always. Well, we find revolutions from time to time. We say that now we are in the fourth industrial revolution. Perhaps it's the 4,000th industrial revolution.
Okay.
Every time there are new technology coming out, new science discovered and affect the engineering. If we go back, say, in the beginning of the 20th century, for instance,
Yes.
we have massive innovations. The first airplane was
Right.
took off the ground.
Okay. It's 1903, something
The
like that.
first radio, people that know here from thousands of kilometers.
Exactly.
The first televisions.
We can see someone over there.
A lot of new things. Then that changed the society.
Right.
So that is again back to our first discussion that engineering and civilizations is two sides of the same coin.
Right.
Because every time we create new things, our behavior also changes. Civilizations change.
All right.
Engineers invent automobile.
Yeah.
People change their life.
Yes. Yeah. Yes.
Engineers invent handphone, cell phone,
We change
the social life.
exactly. We change the way we communicate and interact
Everything how
with
we
people.
communicate.
Mm.
So any engineering inventions create revolutions.
Good
So the industrial revolutions always bring new word.
Okay.
So when we face a new word, then we have to either stay in our cave or move to that new place
Right.
and learn new things.
Wow. Okay.
So that's
Okay.
just the choice is yours to
To
stay in the cave or go outside and discover, adapt the new world. So
Very interesting.
adaptations.
Yes.
We go back to Darwin. The species that is the most adaptive.
Yeah, it will
be
survive,
the
right?
survivor.
Not the strongest, not the biggest.
The strongest, not the cleverest, not the biggest,
All right.
but the most adaptive to the change.
Yeah.
So that is when industrial revolutions come, or where revolutions come, or basically when new innovations come, we have to be able to adapt to that innovations, with the sole purpose is to have a better world,
Okay.
to live a better world.
Right. This is a good point, Rob. Because earlier you mentioned also about when you want to innovate or create something, you need to pay attention or consider the behavior of people. Now I discovered something even better than that. When you create something that will change the behavior, and then with the new behavior, you will need to create something else, something like that. Is that right?
Yes. It's perpetual.
Perpetual, right.
Perpetual. So invention create invention. Innovations create innovations. Another innovation.
Right.
Innovations. For instance, the first ChatGPT comes out.
Yes.
People just amazed with it,
Yeah.
the technology. But now, new economy is coming out
Okay.
from that AI.
Okay, right.
And now, millions of jobs disappeared.
Disappeared.
But at the same time, millions of jobs
Emerged or
emerged.
created.
So this is the challenge of you, future engineers,
Yes. Of you.
on how to adapt and make use of any innovations to add and to use their innovations to leverage what you do,
Right.
to improve the productivity, and most important thing is to make the future a better place to live, a better life to live.
Very good point. Okay, in this case, back to the Industrial Revolution. Of course, we will talk
Yeah.
about that, right, in
Yes.
our lecture in
Yeah.
more details. But basically, I learned something from you. Maybe it is not only Industrial Revolution 1, 2, 3, because we
Yeah.
have maybe a lot in between
Yeah.
already, right? Now, we also learn the word disruption. We always
Yeah.
hear that word, Prof. Maybe you want to say
Yeah, yeah.
something about that.
Sometimes your innovation is just something that we never experienced before.
Uh-huh.
That create disruptions because we never learned about that
Yes.
before.
Mm.
We never know what is this. So
Mm.
when the first automobile comes out from Mr. Ben's garage,
Yeah, right.
people will be just amazed or even
Yeah.
complaining,
Complaining,
blaming,
surprise.
or
Okay.
surprise,
Mm.
shock.
Okay. Okay.
So that is the disruptions.
Uh-huh. Right.
When we so innovations, when it is very fundamental, it creates disruptions.
Disruption. Okay. Okay.
And when we, as I mentioned earlier,
Mm.
it is just like people that used to live in a cave,
Right.
never know about what the world
Looks like.
So looks like, and all of a sudden when he came out of the cave, he surprised with
Right.
new
Okay.
things,
Okay. Okay.
discover
Okay.
new things. That is
And they think that it was all disruption.
all
Ah.
disruptions. So it's his choice, her choice,
Okay.
whether to stay outside and see the wonders and the beauty of the new things,
Okay. Or
or
go back to the
go back
cave.
to the cave.
Okay. Okay. Right.
Already in my comfort zone in the cave.
Ah.
I know every corner of the cave. I'm very comfortable in the cave.
Right.
Why should I go outside the cave?
Uh-huh.
So it's your choice. When you
Okay.
see when you come up with disruptions,
Mm.
it's your choice
Okay.
to
Okay.
embrace
Mm.
for the new world,
Mhm.
adapt yourself with the disruptions
Okay.
that might not make your life easier in the beginning,
Okay. Right. Right.
but you will certainly go into the next stage of your
Ah.
your life, your productivity, your
This is.
engineering practice.
Yeah. So in this case, we can see the disruption as something bad or something that obstacle, or you
Yeah.
can also see it as an opportunity, probably,
Yes.
for it to grow. Right.
Yeah.
Right. Okay. Prof. Nizam, we also we are faced by the rapid development of technology.
Yeah.
Right. I mean, Prof. Nizam and I are from maybe a little bit different generation.
Yeah.
How do you see yourself and also future students, future engineers
Yes.
would need to deal with that kind of rapid development of technology, Prof?
Yeah. Yes.
Mm.
As I mentioned earlier, actually.
Okay.
Yeah. It is either you embrace
Okay.
with new innovations, with inventions, or you stay in your
Okay. Right.
comfort zone.
Mm.
I remember when I was in my bachelor program.
Mhm, mhm.
At that time, calculator become
Yeah.
available chips,
Okay.
and
Calculator.
everyone can buy and use. But
Okay.
at the time, my senior, my lecturers, my professors, some of them are quite comfortable and embrace with the new technology,
Right.
and let students go in the exam to use the calculator. But some are still, no, you have to work out your calculations by the slide rules, for instance. Yeah, so in the end, the one that embraced the new technology wins.
Okay. Right.
Yeah, so adaptations, I think, is a must.
Mm.
New technology eventually will become the normal.
Okay.
So the sooner you
Adapt,
embrace, adapt to the new technology, the better.
The better.
So that is,
Okay.
well, at least my own experience.
Okay.
My 60 years.
So meaning that, Prof, you might not like it at the beginning,
Yeah.
but this is the reality
The reality.
that,
Yeah,
that
the
somehow
reality.
you need to embrace.
Yeah.
So if you,
Yeah. Yeah, indeed. Sometimes innovation is not growing and not bringing us
Okay.
to new or better
Okay.
world or better
Mhm.
situations.
Right.
But at least we have to understand
Okay. Okay.
if it is we feel it's good. And
Okay.
find what's good from these innovations that we
Mm.
can well utilize and improve what we are doing. So, engineering is coming every time to improve our life.
Right.
So let's use that approach. How new innovations can improve the way we do things, the way we solve our problems,
Right.
the way we deliver our solutions.
Okay. Prof, this might be the last segments of our talk, nearly an hour. So I think this is also about the mindset, because that's what I learned from you when you talk about adaptation and things like that. If you have to give a message to our future engineers,
Yes.
what mindset should the student have, in your opinion, in order to be ready to be a future engineer like that?
Yeah. First, I think the most important is growth mindset,
Growth mindset, right?
not fixed mindset.
Okay, right.
Because by nature, engineers, by definition, is to create things.
Okay,
Creations is innovations.
Mhm.
Creation is making something
Okay.
out of nothing. So that growth mindset is very important
Okay.
to be mastered.
okay,
And secondly, adaptability, ability to adapt with the
right.
with the change that's
Okay.
always there.
Okay,
Thirdly, as an engineer,
uh-huh.
we are trained to think systematically, system
Systematic.
thinking,
Okay, right.
input, process, how things work, output, what we deliver, impact of that output,
Okay.
results. So system thinking
Right.
is very important to master. Mindset of systemic thinking. And fourth, collaborative working, ability to collaborate,
with others.
attitudes to collaborate with others,
Right, right.
attitudes to embrace with others, attitudes to
Mm-hmm.
even
Yeah.
partners with people who oppose our plan, for instance.
Uh-huh.
That's very important. So collaborations.
Right.
And for the growth mindset to sustain that,
Mhm.
we have to be lifelong learners. Always
Always learn.
ready to learn,
Okay.
always want to know, always curious about
Okay.
new things.
Right.
So that is, I think, there are
Yes.
of course many things that
Right, of course,
we need
right.
to prepare.
Yeah,
but I
that's a
think that
very
is
good
the-
4 points that you mentioned. Thank you so much. Now, the last question is
Yeah.
maybe a bit specific because we are at the
Yeah.
Faculty of Engineering of UGM.
Yeah.
Do you have any message in specific for our students who are attending this class?
Yes. For engineering students that will take this engineering for civilizations. So be curious and critical in joining the programs and enjoy the class. Let's make our class as dynamic as possible.
Right.
It depends not only for
Us?
the Andi or me, but it depends on you.
All right.
Let's make it a vibrant and joyful and enjoyable class.
Prof, thank you very much.
My pleasure.
Not only
Yeah,
students, I believe I also learned a lot from you. Thank you very much.
My pleasure.
And by the way, thank you for watching, and I hope you will be here also for the next session. Bye bye. Thank you so much.